Scientific diving is a specialized type of diving that marine researchers will use to set up experiments, collect data, and make observations in the marine environment. Scientific diving is a little different from recreational diving in that it's a little bit more specialized. Most of the people who are scientific divers already are trained in a particular discipline, whether it's archaeology, geology, biology, or chemistry. And scientific diving is regulated by a group known as the American Academy of Underwater Sciences.
My definition of scientific diving is diving that is used for the advancement of science, and that's different from commercial diving. Commercial diving is where you have heavy construction or underwater cutting or welding going on. You're using heavy lifting techniques. Scientific diving is where you actually have a job to do. That's for the advancement of science, and that is your primary goal for going down there and actually carrying out research. That differs from recreational diving, in that recreational divers typically stay fairly shallow, and they're just happy to be down there underwater using scuba, being able to look around and just kind of observe, whereas scientific divers usually have a useful purpose in carrying out fish observations, mapping, survey work, light lifting, things of that nature. But basically it needs to be done, the science needs to be done, and that's carried out year-round. Example, we have a project going on. We're going to be going out on Thursday. Water temperature is 51 degrees. Visibility is probably going to be fairly limited, but it has to be done. It's not conditions that recreational divers would want to be in, but because we're doing it for science, it needs to be done, and we go out there and take care of the job.
Well, scientific diving covers a lot of things in diving. You can do scientific diving for research, marine biology, marine geology, learning scientific method is part of scientific diving. So it really covers a lot.
Diving is a really important tool for marine biology research. There's a lot of things that we can't know about ocean life without actually putting a scientist underwater. So if you think back before the advent of scuba diving, what we knew about benthic communities, the communities of organisms that live on the seafloor, was what we could catch with a line and reel or pull up with a trawl. So these methods of studying ocean life are very crude and very destructive to the organisms, and they didn't allow us to know much about the relationships among the organisms, just to say, oh, something that's soft-bodied and squishy and beat up lives down there. Scuba diving is essential for this field because it's the only way we can get an actual scientist there. There are remotely operated vehicles which are very powerful in helping us get to places that people can't go.
An ROV is a remotely operated vehicle. That means it is tethered to the vehicle or to a vessel via an umbilical that is could be a different distance, could be a very short one, it could be a very long one, and it is controlled from the surface of the ocean on the vessel via an operator. ROVs are very important in the field of scientific diving for many reasons. One main reason is ROVs can go to very deep depths. The typical diver really can go to 130 feet, and the ROV can go anywhere from 100 feet down to several thousand feet, several thousand meters. The ROV can also collect samples and do most things divers can, and you can also put different instrumentation on ROVs to collect different data, whatever the primary scientist needs at that point in time. Now that ROVs are around the world, exploration can be done in places that they could not be done before. Like I was just saying, in the water depth for divers, 130 feet is the typical max depth for a regular diver, and it could be up to 1,000 feet with specialized commercial diving. But now with ROVs, people are researching in the deepest parts of the ocean and finding different sponges and corals and different habitat. So now that ROVs exist, people are doing multitude of deeper depths dives and longer dives and things like that. Some other things that make ROVs special are they can actually do work. So like a human being, you can attach different manipulators, which are robotic arms on the ROV. And with that, you can actually screw nuts in different devices on like a drill rig, or you can do all types of work. You can pick up samples from the bottom of the ocean and collect them in a bin and bring them to the surface, or different things like that. The main reason you use an ROV over a human diver is because of water depth. Divers only go 130 feet or a little bit more than that, and ROVs can go very deep. I guess the other main reason why ROVs are better to use than human divers are because they can stay down for an infinite amount of time. If you're taking a diver to 130 feet, they may only have 20 minutes on the bottom, then they got to come up and start decompression. As a ROV can stay down for several days at a time, as long as you have as many operators as you need to drop the ROV.
It's had great influence on marine discoveries. Before scientific diving was made available to researchers, the best that they could do for example, collecting items off the bottom like jellyfish or shellfish or other types of fish were basically by either dredging or dragging nets. And a good example of analogy is I've heard it repeated many times, is if they wanted to collect rainforest insects over the Amazon, what they were doing with the dredge and netting techniques was basically like dragging a butterfly net, but with a low-flying plane over the Amazon and hoping to collect various things. It just wasn't effective. There's so much more that they were missing. And it wasn't until the advent of scuba diving that allowed scientists to get in there and actually see what was down there and see the interaction between different species of fish, different organisms, and actually do collecting and manipulating and get their hands on what they've actually been wanting to collect and research.
Before the advent of scuba diving, our only way of knowing anything about life on the floor of the ocean was by pulling it up from the bottom of the ocean in very crude methods that often destroyed the organisms that we were trying to study. Furthermore, when you pull organisms out of the water, you can't study anything about their interactions. By putting scientists with scuba tanks in the water, scientists can conduct manipulative experiments in situ. They can observe the distribution and abundance of organisms together. These are all basic questions in ecology that were completely off limits to scientists beforehand. And
in-house, we have Dr. Joe Pollitt, whose main primary focus is researching sponges and their chemical compositions. And as I've talked to him in the past, there are so many different natural products that are derived from marine species. And the last time I talked to him, he said there's over 21,000 natural products that have been derived from marine organisms of various kinds, that they're used primarily in things like cosmetics, skin care, and the main one that everybody's concerned with is pharmaceuticals. And that's what he is researching. But there's so much that we haven't discovered yet. But these are all things that, of those over 21,000 products, if we didn't have scientific diving, we wouldn't be able to accumulate anywhere near that number. And other ways that we've seen, that I've seen scientific diving advance exploration is several years ago, back in the early 2000s, we had a project where we were helping to map the wreckage of the USS Monitor, Civil War ironclad, and that sank in 230 feet of water off of Cape Hatteras. And at that time, they wanted to salvage large parts of it, including the propeller, the shaft, the turret, the actual revolving turret, which was the first revolving turret ever put on a vessel, and also the engine needed to come up. And they used divers. They used divers from our program here to actually go in and do the preliminary mapping before any of these items were removed. And that would have been next to impossible with a remote operated vehicle. You just can't do it. You need to have hands on. The ironclad is upside down. It's in 230 feet of water. Some of the spaces were very tight to get into and map and measure. And that couldn't have been done without scientific divers. And if we weren't able to measure that in place, the marine archaeologists would not have given the Navy permission to actually go and remove it and to place it in conservation in the museum. So these are two of the things that just focused by UNCW that had captured marine discoveries by using scientific diving.
Right. Archaeology is the study of artifacts that are left by people. Underwater archaeology is the study of artifacts left by people usually on shipwrecks. Sometimes we have light towers, lighthouses that are left, a number of things, but it's cultural remains left by people is what archaeology, the study of archaeology is. And underwater archaeology is the study of cultural remains under the water. Diving is important in underwater archaeology because there's not another way we can get down and we call it ground truthing. Ground truthing what we find. We use a magnetometer, which is an instrument that picks up the magnetic signature of the Earth. And this signature is always there. And if there's something metal, ferrous material, it creates an anomaly, which is a change in that signature. And that's when we see maybe a shipwreck. We don't know if it's a shipwreck until we go down and dive on it and take a look at it, or usually a feel of it, because the water is usually dark where we work. We are archaeologists, so usually there's a grid that we use, and we take the artifacts up only after we take the sand away around the artifacts. We draw the artifacts, we draw the shipwreck, we take pictures if we can. Only then do we recover and remove the artifacts. So someone needs to be trained in this kind of work in diving for underwater archaeology. Usually we use students from the East Carolina Maritime History Program. Well, the find of the Queen Anne's Revenge was found by a group called Ingersoll. They're treasure hunters, and they found the Queen Anne's Revenge, but because it was in state waters, which is within the 3-mile limit, the Queen Anne's Revenge site belongs to the state of North Carolina. So we've been working on the Queen Anne's Revenge site since 1997, and we are excavating the site slowly. And just as I stated a minute ago, we lay out a grid. We suck up with these induction dredges. We suck up the sand around the artifacts, and that goes up to a sluice box on the deck of a barge, and then, only then, is it drawn. We tag the artifacts, and then we lift them. So the large artifacts, like cannons, are a little different. We have to chip away around the outside, because artifacts that are metal, that are under the salt water, have a concretion around them. It's like cement, and you have to separate that artifact from whatever it's around. So these cannons are covered with other artifacts in this concretion. So we have to separate the concretion a little bit, and then we put straps around the cannon. We remove it from the site, put it in the sand, and then we strap it up, put it on a lift bag, and have another vessel come out and pick it up for us with a big crane.
Myself, I'm a marine electronics technician, so I'm responsible for deploying and maintaining a lot of specialized electronic equipment. In most cases, the pieces of equipment are very sensitive and require a very gentle touch when they're being deployed. In some cases, the equipment has to be deployed in a particular orientation or at a very specific location. So scientific diving allows me to have a tool where we can actually make sure that the instrumentation is set up correctly when it's deployed.
I do a lot of scuba diving. My work is entirely based out of the Caribbean, and I'm asking a research question that requires scuba diving. So I want to study coral reef communities, and the part of coral reef communities that interest me are the sponges. So when you think of sponges, there's lots of things that come to mind that are probably not what I'm talking about. Sponges are a type of invertebrate animal that lives on the bottom of the ocean and feeds by pumping water through its body. Now in the water there's plankton, there's detrital material, there's all kinds of food stuff, and that's how sponges feed. They live off of that. And sponges are becoming increasingly important in the Caribbean because stony corals are starting to decline and algae are becoming abundant. Sponges are just now more prominent part of the ecosystem than they were before. And so understanding aspects of their ecology is really important if we want to understand the future of coral reef communities.
I've been doing this for 29 years, and every year, every dive is different. You never know what you're going to see, what you can expect, and you are very much made aware that you are not a natural underwater. As much as you would like to think that you're a water rat, and you know how proficient you are in either scuba gear or skin diving gear, it's very humbling to come and encounter dolphins, sharks, manta rays, anything else that we occasionally encounter underwater, and they are just so natural in water. And like I say, you really feel like a visitor, a foreign visitor. And like I say, you just never know what you're going to find, what you're going to see. And me, like a lot of other people, I've taken to carrying a GoPro video camera around with me. It's small, lightweight, fits in the pocket, just because there's so many opportunities of seeing and recording some really neat critters down there that you know otherwise have been missed. So.
For example, right now a couple of my colleagues are working on describing a new species. They found an octocoral that is a soft coral on the ledges off North Carolina here, where and it's a species that's never been described before. They're not sure if it's an invasive species or if it is just something that is completely new to science, but in this case, having scuba divers underwater allowed us to encounter this new organism, and it's giving us the opportunity now to start to learn things about it. That work's still in progress, but scuba diving was essential for that discovery of that organism.
There's any number of ways that scientific diving's influenced marine discoveries. You can look at biology. You've got researchers like Richard Pyle, I believe his name is, who is using rebreathers to dive very, very deep depths, greater than 200 feet, and it's helped him in the discovery of lots of new species of fish. You have the underwater archaeology branch at Fort Fisher. Marine or scientific diving has allowed them to do a lot more close-up research and work on the Queen Anne's Revenge up in Beaufort.
Diving is an important part of marine exploration because it allows an actual person to be underwater and to actually see the things that we're trying to explore the way that they are. Other means of exploring the oceans have a variety of different types of limitations, but you can imagine that there's no way that anything but a diver could go underwater on, say, a shelf here in North Carolina off the coast and be able to explore the types of benthic invertebrates and algae that grow on the underside of that ledge. Really the only other way you can study that is by crudely tearing it off of the bottom with either a robot or trawl net or something.